You all are welcome to the session of engine system and performance. Today we shall discuss about electronic ignition system. And before going to discuss about this particular topic, that is electronic ignition system, let us first discuss or recall the conventional or battery ignition circuit which was used to produce energy to produce spark. So, if we look at the block diagram or schematic depiction of the ignition coil, that is battery ignition coil, we can see there are several elements or components, and we can see that this is essentially a battery. So, if we write this battery is basically 10 to 12 volt, we have ignition switch, and then this resistor is provided to the circuit, provided with the circuit, and we can see that there are two different circuits in this coil, or two different coils rather in this circuit, whatever you would like to tell. So, this is primary circuit, and the upper one, that this coil or circuit is the secondary circuit. So, we can see that there are two coils, primary coil and secondary coil. If we look at the components which are there in the right hand side, this is these are the breaker points. So, these are the breaker points, and these opening and closing of these breaker points are done using this breaker cam, and this cam is essentially connected to the engine shaft, and in tune with the engine speed this cam will rotate, this breaker cam will rotate, and it will be used to open and close the breaker points. While we can see that this is the primary coil. So, this is primary coil, ignition coil rather, and the upper one is the secondary ignition coil. Okay. And the secondary ignition coil is connected to this distributor shaft. So, this is distributor unit which is having a distributor shaft. So, this is again distributor cam. So, ideally this would be connected to one of the, so this cam is connected to one of these point, and when the cam is this cam will be rotating, again this cam is connected to the engine shaft, and when the cam is getting connected to these points in a cyclic manner, when it is connected to the upper point, then this point is getting charged and energy is going to the spark plug of, if it is a multi-cylinder engine, then essentially the energy will be going to all the cylinders, I mean the spark plug of all cylinders. Now, let me discuss about the functioning of the circuit first, and then probably we will see what are the limitation of this and what is the need of electronic ignition system. So, when these breaker points are in contact, so closed to be precise, and if we switch on or if we turn on the switch, so this is ignition switch, ignition coil switch. So, when the breaker points are closed and if we turn on the ignition switch, a battery current will will flow through this primary coil, and it will essentially go to this condenser. So, this is the condenser, and condenser will be charged. Okay. So, breaker points are closed. If we turn on the switch, the battery current will flow through the circuit and it will essentially go to this condenser to charge it. Now, when a current is flowing through the primary coil, then a magnetic field will be induced, right. And because these are the coils, these coils are made of iron core and iron core is wound with copper wire. So, these are basically primary and secondary coils. Now, when a magnetic field is getting induced, that building process, the induced magnetic field will cut the primary winding, and that process will create a back EMF, and that EMF will again resist the primary current, that is battery current. So, when we turn on the switch, a battery current will flow through the circuit, and when the current is flowing through the circuit, as I told you, this coil is made of iron core and the iron core is wound with copper wire, and a magnetic field will be induced, and that magnetic field will create a back EMF, back electromotive force, and that back EMF will try to oppose the primary current or battery current and delaying the building up process. Now, this magnetic field essentially will expanding. So, magnetic field will expand, and upon expanding it will cut the primary windings, and then back EMF will be developed, and that will oppose the primary current flow. So, if we look at, or if we try to draw the development of the primary current with time. So, if it is time t, if this is primary current, then essentially it would be delayed. So, if we take the slope from there, so this is basically the building up process. Now, question is, as I said, these breaker points are closed and opened by a cam, and that cam is rotated by the shaft, that the cam is connected to the engine shaft. So, the cam will again, if the battery point, these breaker points are are getting unconnected. So, that is if we open the breaker points, then what will happen, whatever magnetic field was induced therein in this ignition coil, that magnetic field will collapse suddenly, and it is because of this collapsing the magnetic field, again a current will be induced. So, this is the electromagnetism. So, the current will again try to flow in the primary circuit. So, when the breaker points are closed, then also a current is flowing through this primary circuit, that is the battery current. If we open these breaker points, again a current will flow in this primary coil or through the primary coil, that is because of this induced magnetic field, and that current also will try to charge the condenser. Now, what we see, the moment we close the breaker points, the magnetic field will collapse suddenly, and then this current will drop. So, this process, so when there is a magnetic field, when the magnetic field is induced here because of this battery current flow, that also will try to produce some EMF in the secondary coil, but that EMF or that voltage is too low for a spark plug to produce a spark. But when the magnetic field that would be induced, that induction of magnetic field will try to create, or that will develop a back EMF, that EMF will try to oppose the primary current flow, and when we close this when we open these breaker points, magnetic field will collapse suddenly. It is because of this collapsing the magnetic field, another current will flow, and which is in the same direction of the primary current or battery current, and that sudden collapsing of magnetic field also will create huge voltage in the primary circuit or primary coil, and even higher voltage in the secondary coil. So, because of this collapsing of magnetic field, the EMF or voltage will produce in the secondary coil is of the order of 10 to 20 kilovolt. So, EMF or voltage that will develop in the secondary coil due to collapsing of the magnetic field. This magnetic field is induced. Okay. So, because of this collapsing of the magnetic field, voltage that will develop in the secondary coil is of the order of 10 to 20 kilovolt. As such, this much voltage is needed. If we now draw the the spark plug is like this, the gap in the spark plug, see the small gap is 1 to 1.5 mm spark gap. So, this small gap, if we need to break the resistance of this small gap, we need this much or high voltage 10 to 20 kilovolt. So, try to understand using the battery voltage which is 10 to 12 volt small EMF or voltage, we could produce a significant voltage in the secondary coil or significantly higher voltage in the secondary coil, which is 10 to 20 kilovolt, and this is needed to break the resistance of this gap, so that spark will be produced in the spark plug, and that will be used to ignite the combustible mixture or fuel air mixture in the engine cylinder. Now, so what we can understand from the circuit is the primary coil is the main coil for this, and the breaking of the primary coil. So, essentially we need to turn on the ignition switch when the breaker points are closed, then only a current will flow, and it will develop all this, initially a back EMF, magnetic field, and then again you need to collapse the magnetic field by using these breaker points. So, breaker points are responsible to close the primary coil and also to break the primary coil. So, closing and breaking the primary circuit is done by the closing and opening of the breaker points. Now, the breaker points opening and closing, this process is done by this cam and which is connected to engine shaft. So, any mechanical device, any mechanical component is having some inertia. Over and above, if engine speed increases, then this closing opening time will be very less. So, that duration between two consecutive closing and two consecutive opening will be less, and if the closing and opening time becomes lesser, then you can understand the current or voltage that will produce in the secondary coil may not be that much high. So, because it takes some time for the development, again it needs some time for the collapsing. So, that means you can understand that this much time is needed for the development and this much time is needed for the collapsing. So, this is T1 and this is T2. Now, if T1 and T2 are getting reduced because of the engine speed, then the energy that would be available at the spark plug will be less to produce a spark, and hence it would be very problematic for an engine to operate. Another question is that if I write here that higher engine speed, okay. So, it is well known that number of pulse or spark, or I can write spark produced per second is proportional to number of number of spark produced per second, I should write, is proportional to the engine speed. So, if I write it is proportional to engine speed. What does it mean? It means if we increase the engine speed, then number of spark to be produced per second will be more. So, basically question is, if we look at this battery ignition coil is okay so long as the engine speed is low. So, if the engine speed is not very high, say for example up to 3000 rpm, this particular ignition coil is reliable and cost effective, because we can see there, in this circuit we have the primary coil, we have distributor cam, we have a resistance, breaker points, but we do not see any very costlier element or component attached to the circuit. So, if the engine speed is up to 3000, so if the engine speed is up to 3000 rpm, then battery ignition coil is reliable as well as cost effective. But the question is, when engine speed is very high and say for example for the racing cars, engine speed is very high and even beyond 5000 rpm. Then this particular coil or circuit encounters a few problematic issues, mostly related to inertia, because you can understand this cam is driven by a camshaft which is connected to the shaft of the engine, and any mechanical component or mechanical device is having some inertial or some inertial impact or issue, and as a result that closing and opening of the breaker points will be a problematic issue to produce sufficient energy needed to develop a spark by a spark plug. So, if the engine speed increases, as I said you, that this would be so fast that primary coil, there will be some current flow through the primary coil, but either collapsing will not be proper or collapsing of the magnetic will be delayed, or even building process would be delayed. So, these two process, building of the this current which is flowing through the primary circuit, that is building up the current, as well as collapsing the current, because of this collapsing the magnetic field will be delayed, which in turn will delay the produce some problems to develop high voltage in the secondary coil, and you can understand if the voltage is not proper, then it is not possible to break the resistance in the gap, small gap which is needed. On the other hand, nowadays the demand is, as such this problem becomes even more acute on engine that demands high number of spark per second, for say for example for high speed engine, and also for engine that multi-cylinder 2-stroke engines. In those cases the number of spark to be produced per second is more, and such a scenario this battery ignition coil is not suitable. Another important issue is, nowadays the trend is to have a transitioning from, so I am writing here, transitioning from the stoichiometric burn engine to the lean burn engine. So, this is the modern trend. This modern trend is quite realistic, because if we try to shift from a stoichiometric burn engine to a lean burn engine, then the requirement of fuel will be less, and if the requirement of fuel is less, emission will be less. So, we can have highly efficient engine. So, if we need to shift from this stoichiometric burn engine to lean burn engine, which needs kind of less fuel to produce same amount of work output, and then question is this particular transitioning or shift demands for large or wide spark gap. So, if the gap is that wide, so you can understand if the mixture is having lean mixture. So, if the mixture is lean mixture, so mixture is having less fuel. So, sparking should be more, or energy that we need to supply to the spark plug should be more to ignite the fuel air mixture. So, in such a case, the spark plug which should be used to ignite the fuel for a lean burn engine, this gap should be more wider, and if the gap is wider, then we need to have spark for a long time. So, demands for larger wider spark gap, which in turn demands for longer duration spark. So, that means we need to produce spark for a longer duration. That means we need to supply more energy to the spark plug, right. So, this can be achieved. So, more energy to be supplied to the spark plug, right. So, question is, using a battery ignition coil, we cannot have all these advantages. So, that is why we need to think about some modification of this ignition coil, and that modification is essentially again with the help of some electronic circuits, electronic gadgets, electronic devices. So, as if we can see, having a look at the schematic depiction, we can see mostly all components are mechanical component, and using these mechanical components or elements, if we would like to overcome all these challenges, that means if the speed increases, we need constant source of constant energy supply to the spark plug. If we need to shift, and which is the modern trend from stoichiometric burn engine to the lean burn engine, you can understand to burn that lean mixture we need to supply more energy. So, the spark plug will be having wider gap. To break the resistance of the wider gap, we need to supply more energy for a longer duration. So, all these things, all these challenging aspects cannot be fulfilled using battery ignition coil or battery ignition coil. So, that is why the electronic injection system was introduced. So, electronic injection system, if I now write electronic ignition system to be precise, not injection, electronic ignition system. Let me tell you, if we go back to the previous circuit, so essentially we need to have primary coil, secondary coil, etc., but in electronic ignition system, these breaker points are replaced by a sensor, and so breaking and unbreaking or closing and opening of the primary circuit. Now, what we can see in the circuit is in this system is done by these breaker points, but in electronic ignition system, opening and closing of the primary circuit is done by the sensor. So, breaker points are replaced by a sensor, that is all. So, as I told you, that electronic ignition system, so all these problematic issues cannot be managed by the battery ignition coil, and that is why this electronic ignition system was introduced. This particular system differs from, so this particular system is different from the battery ignition system from the following perspectives. What are those? First of all, I told you that the primary circuit, this primary circuit is different in electronic ignition system. This circuit is different in electronic ignition system in from the perspective of the breaker points are replaced by a sensor which is called pulse generator, which is called as the pulse generator or trigger. Okay. So, we will not have breaker points, rather we will be having a sensor, and that sensor is known as pulse generator or trigger. While the secondary coil, the secondary circuit or coil is typically the same for both the systems, that is electronic ignition system and battery ignition system. Now, in this context, two different philosophies have been proposed. So, the first one is constant dual system, second one is constant energy system. So, constant dual system and constant energy system. So, these two different systems are developed essentially to modify the battery ignition system, and these two strategies have been developed to improvise the battery ignition system and to meet the requirements of modern engine, essentially from the perspective of less emission and higher performance. So, let us talk about constant dual system. So, if we focus now our discussion on constant dual system. The term, this term dual, which when applies to ignition coil, this term dual, when it is applied, to ignition system, is defined as the time duration during which the primary coil is charging. Right. So, this is called dual, constant dual. Now, question is, we have seen, we have discussed today that charging of the primary coil, if we go back to the slide. So, you can see that this is the charging time, right. So, T1 is the charging time and T2 is the discharging time. I can't say discharging time, when magnetic field collapses, still there are some current flowing in the primary circuit and charging the condenser. So, T2 I should not write the discharging time rather. So, this is the very first it collapses, and this charging time which is very important, and this charging time, as I written over here, that dwell time. So, that is basically the time needed for charging the primary coil. So, even if we have considered battery ignition coil, had we considered the constant movement of the breaker cam, no matter whether the what is the engine speed, what the engine speed is rather, that opening and closing time is fixed, then the charging of the primary coil will remain same and the dwell time will remain same. But that is not the scenario in the battery ignition coil, because breaker cam is connected to the shaft wherein, or connected to the shaft of the engine speed. So, if the engine speed changes, the closing and opening time will be changed, which in turn will change the building up time or charging time, and then it will disturb the sparking or spark energy supplied to the spark plug. So, what we can do, we can have one constant dual system, no matter whether the this closing and opening point or closing and opening time of the breaker points is getting disturbed because of the engine speed. We can have a circuit or electronic system which will allow a constant dwell time. So, even if the engine speed increases, dwell time or dwell angle will remain same, but the actual time will reduced. Okay. So, this is the concept of constant dwell system. So, if the engine speed increases, say think about battery ignition coil, then what will happen? You know that when breaker points are getting connected, that time will be very small and the building process will be delayed. Now, if the engine speed is too slow, then it is not possible to even open the breaker points. So, the breaker points will remain almost close. In that case, collapsing of the magnetic field will be delayed. That discharging time will be very lengthy. So, in that case, it is not possible to meet the requirement. But now, using this constant dwell system, we can have constant dwell time, that is the charging time required to primary coil will be the same irrespective of the engine speed. If that is the scenario, we can always supply certain amount of power to the spark plug through the secondary coil or secondary circuit. Second is, but this particular constant dwell system is now almost replaced by, without exception, constant energy system. So, if I write here constant energy system. So, in the constant dwell system, if we need to have constant charging type, that is the primary circuit will primary coil charging time will remain constant irrespective of the engine speed, certainly we have to have an alternative way out, so that closing and opening or breaker points will not be there, rather that primary circuit would be controlled by an electronic control unit. So, we need to supply some pulse to the primary circuit to open and close irrespective of the engine speed, and that is what is done using this electronic ignition system. Now, as I said you, now constant dual system is also totally, or I can say almost replaced by without exception the constant energy system. What is this constant energy system? So, if we go to the next slide, then we can say this constant energy system, that as I told you that the modern trend is to shift stoichiometric burn engine to lean burn engine. So, if it is a stoichiometric burn engine and the energy that we need to supply to the spark plug is 0.3 millijoule. So, if I write, so for a stoichiometric, that is chemically correct air fuel ratio, stoichiometric burn engine, energy requirement to the spark plug to produce a spark is 0.3 millijoule. You can understand, very less stoichiometric air fuel ratio, that is chemically correct air fuel ratio. Now, if we shift, so shifting to a lean burn, it is not always a lean burn, even if it is a rich burn, engine. So, if it is a lean burn engine or rich burn engine, rich means the mixture is far away from the stoichiometric mixture, stoichiometric ratio. So, either fuel is rich with the air or the air is having less fuel. So, the air will be having more fuel or less fuel. So, in such a scenario, the energy requirement is 3 to 5 millijoule. That is what I can tell, 3 to 4 millijoule. So, you can understand, if we do not use electrically or electronically operated ignition system, if we need to rely on mechanically operated battery ignition coil, then if we need to shift from stoichiometric burn engine to the lean burn engine, then the energy requirement also changes, and that energy requirement will not be fulfilled by the mechanical components or mechanically operated battery ignition system. Okay. So, what is done essentially? So, can we supply a constant energy irrespective of the lean burn or rich burn, so that the engine will always supply a fixed amount of energy to the spark plug, and that much energy will be obtained from the ignition coil. So, if we need to have such favorable or such advantages, then the opening and closing of the breaker points will not be there. Primary circuit will be activated, primary circuit will be deactivated using a sensor, and that sensor is essentially pulse generator or trigger, right. So, from here we can say, so the need is to have a constant energy system accounting for this aspect, that is the mixture can change from stoichiometric to lean or rich, this is constant energy system to meet the emission, or I can say emission criteria and expected or desired performance. In fact, all modern engines are now equipped with electronic ignition system of constant energy type. So, as I told you that in electronic ignition system, breaker points are replaced by a sensor which is known as pulse generator trigger, and this device generates a pulse to signal to inform the spark when or to spark plug when a spark is needed. So, let me write here. So, in electronic ignition system, breaker points are systems, I should write, are replaced by a sensor which is called pulse generator or trigger, right. By a sensor, this device generates a pulse to signal to inform the control unit of the system, to control unit, that is ECU rather, to develop a spark, to develop, or rather I should write unit when spark is needed, I should write spark of required energy is needed at the spark plug. Right. So, this is the difference of between electronic ignition system and battery ignition system. Now, let me tell you, so when trigger produces a spark, so when the pulse generator or trigger produces a pulse, that using that pulse the control unit breaks the primary circuit and gives some information or some level of energy to the secondary circuit to produce the desired spark. Let me repeat once again. Pulse generator or trigger, when trigger or pulse generator produces a pulse, that pulse is able to break the primary circuit and that circuit will be able to produce sufficient voltage to the secondary coil that is required to produce a spark. And three different types of pulse generator are used typically for the electronic ignition system. So, I should write in the next slide three different types of pulse generator or trigger are used in the electronic ignition system. Number one is inductive type. Number two is this is inductive type, then this Hall type, and number three is optical type. So, these are the 3 different types. So, to summarize our today's discussion, we have discussed about the battery ignition system which was used in old engines. We have identified the functioning of the battery ignition system. Thereafter, we have discussed about the limitation of this particular system in the context of variable speed engines, and also the present requirement of shifting or transitioning of transitioning from stoichiometric burn engine to lean burn engine necessitates some amendments of the battery ignition system, and considering all these aspects or rather challenging aspects, those are not really possible to meet, those are not possible to overcome using those challenging aspects are not possible to overcome using a battery ignition system. The concept of electronic ignition system was introduced, and then we had seen in the context of electronic ignition system there are 2 different philosophies, and one is constant dual system, another one is constant energy systems. Thereafter, we had seen that in electronic ignition system breaker points are replaced by the sensor, and the sensor is very important part to break the primary circuit which is responsible for the development of huge voltage in the secondary circuit. And finally, we had listed down 3 different types of pulse generator, those are typically used in the electronic ignition system. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.